We are going now. Okay. Lesson 2.5. We're talking about scatter plots and lines of regression. Now, the main thing I want to focus on is the scatter plot. Okay? Let me kind of review where we've been. On Thursday, we talked about functions. What's a function? What's not a function? On Monday, we talked about linear functions. So what makes a function into a linear function? On Tuesday, we talked about how to find the slope of a line. And yesterday, we talked about how to write the equation once you found the slope, with a point and the slope, or just 2 points. Now, today we're going to use everything that we've learned so far, basically, to come up with an equation that we call a prediction equation. So our goal here is to come up with a prediction equation and to use that equation. All right? Okay, talking about scatter plots. You've been doing these since middle school. Teacher gives you stuff, you sit there, you put dots on a graph, okay? Now, if you think back to 7th or 8th grade when you started these things, the first thing that you did on your scatter plot was you just put the dots on there and turned in the paper. You made the scatter plot, okay? Then later on, probably in Algebra 1, they had you draw a line, something called a line of best fit for that scatter plot. Algebra 2, what we do now is we take what you've learned in those two classes and we have you write an equation for that line and to use that equation to make a prediction. So what I'm going to do today is I'm going to lead you through this with one example here, okay? And we're going to show you how to do it, and then I'm going to let you work on it. If you take a look at your worksheet today, how many problems do you have on your worksheet? You got 3. There's not many problems. Anytime you see that happening in here, you know that each problem requires a bit of work, okay? All right, so let's start off just by kind of refreshing your memory on a scatter plot. All right, if you got this scatter plot made and the dots line up, let's just say they kind of line up and they're going uphill such as that. That's what we call a positive correlation, all right? Think of a positive correlation like this. The temperature outside is one set of data. Sale of ice cream cones at Brahms is another set of data. As the temperature increases, do the sale of ice cream cones go up or down? They go up. Go up. Nobody eats ice cream in the wintertime. All right. Okay, I do too, but not as much. All right. So, as the temperature goes up, the sale of ice cream goes up. That's what we call a positive correlation. Okay? Now, a negative correlation would be, on the other hand, temperature and the sale of hot chocolate. As the temperature increases, the sale of hot chocolate goes down. That's a negative correlation. Now, out of these two types of correlation, if you can find a correlation, there's a strong correlation or there's a weak correlation. Now, when we're taking a look at this one right here, okay, notice how your dots right here are all kind of lined up close together? That would be considered a strong correlation because they're close. Now, over here on this one, do you notice how the dots are a little further apart? Got some sticking out way over here, all that. That's what we would call a weak correlation. All right? So the closer the dots are together, the stronger the correlation. That means that the information, the two pieces of data that you're working with are very closely related. Okay? All right? And then if you take a look at this example right over here, whenever they're not even arranged in any way, shape, or form, there is no correlation there whatsoever. So what I want to do here is lead you through a situation in which we're going to make a prediction equation. Now, what I have here is a graph that we use on Fridays. You all have your own copies. You'll be using them again tomorrow. But this is a classroom graph from, I believe it was last year, kind of 3 or 4 weeks into the year. And you can see that we're going to be doing that in here. But as we go through and we graph how many you get correct as far as percentage, the computer automatically puts in this line that you can see right there. Okay? It adjusts that line each time I put more data into it. And that's basically a prediction line. That will help me see about how far I need to go to make sure that you're going to do well on the end of instruction test. For example, if I wanted everybody to make an 80 in this class, I'd have to follow that out and see, and if they followed the trend, about 17 weeks in. if everybody kept doing what they're doing. Does that make sense? Okay. All right, so now then, let me take you through this. Here's the situation. The table shows the amount of ice cream, Sunny homemade ice creams sold for 8 months. Okay? Now, to me, this looks like it's probably a running tab, you know. It's going up and up and up and just continuing up. I don't know if it's going to go back down or what the case may be. But it says right here, let x equal 1 for January. So this right here is 1 and 2 and 3 and so on. All right, step 1, we have to make a scatter plot. So we're going to take this, we're going to put it on the plot. You're not going to get them exact, okay? Just get them as close as you possibly can. So for January, all right, I had 37 gallons sold. So in January, I go up to somewhere where I think 37 might be, and I put a little dot somewhere around there, okay? February, I've got 44, which would be, around right there. March, I've got 72, which would be up about here. April, I've got 105, which looks like it's going to be right about there. May, I'm off somewhere, all right. April, how bad did I mess it up? That's better. That look good. That look good. I have to remember to lock that down so I don't move it. Okay, where was I? April had 80, right? So that's going to be right about here. May has 105, right about here. June has 110, which is right about here. July has 119, which is about right about there. And August has 131, which is going to be, that's 19, 20, 31. Now notice, I didn't take a lot of time to try to get them in the exact location, but they're close. All right, that's what you would have done in pre-algebra. Then you would have moved on. Okay? Now we're going to make a line of best fit. Okay, so what we got to do is we got to take this line, and I always start off, and it's best if you can use a ruler that's, you know, or a straight edge or something that you can see through, but if not, I mean, it's fine, you just do this. Don't actually make the line on your paper first. I always draw a line from my first set of data to my last set of data. Now I look at this line. Does this line represent the data? I'm looking to see if I've got the same number of dots above as below. What do you think? Doesn't on this one, doesn't. I've got more dots above than below. So then what I do is I go through and I adjust this line. Okay, I'll move it to a different dot. I went down. Make sure it's going through that dot. Is that better or worse? That's better? That's worse. I've got more dots above now, and they're further from the line. So let's go back and let's take this one. All right, let's go to this end and do some adjusting. Let's take this end and make it go through that point right there. Is that better or worse? That one's better now, okay? So now we've got our line. It's imperative, it's important that you make sure that that line is going through 2 of the dots that you graphed. I can see it's going through this one right there, and I can see it's going through this one right here. This set of data right here, the first one in January, that's this. And then April, we're not worried about that one right now because I'm trying to get them as far apart as possible. That's going to give me a more accurate representation. Okay? All right, and the other one was June, which is right there. Okay? Now, what we do this information now, we've got 2 sets of data. On this first one right here, for January, that's the ordered pair 137. For June, that's 6, 110. Now, once I've got 2 points like that, I can go back to what I did yesterday, and I can write the equation. All right? So now, everything else from this point on is from yesterday and earlier. Let's take a look. 137. Okay, 137. And my other point was 6, 110. From yesterday, what's the first thing I need to find? The slope, thank you. Okay, so let's find our slope. All right, remember your slope formula. Slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so going through here, y sub 2 is 110. Y sub 1 is 37. Here, x sub 2 is 6. X sub 1 is 1. All right, now we got to do the math the rest of the way. 110, okay, follow along here. I'm going to show you how to do this in your head real quick. 110 minus 37 is the same as saying 100 minus 27, which is the same as saying 80 minus 7, which is 73. Did y'all catch that?
No.
All right, 110 minus 37. That's the same as saying 100 minus 27. I took 10 off both of them. Which is the same as saying 80 minus 7. I took 20 off both of them. 80 minus 7, I can do in my head.
That's really tight, bro.
Well, thank you. Thank you. I appreciate that. It makes me feel cool when somebody calls me bro. All right. 6 minus 5 6 minus 1 is 5. So I've got this number, 73 over 5. At this point now, you can just calculate that out if you like. All right, 73 divided by 5. I do like to use decimals when I'm dealing with this type of situation, okay? 73 divided by 5 is 14.6. All right, so that's 14.6. That's my slope. Okay, that's from yesterday. Let me get this. I know. Let me undo that. There we go. I'm looking for this button right here so that I can do this, 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 and that. Okay, now that I've got my slope, I'm ready to go ahead and find my y-intercept. What is the slope-intercept form of your equation, ladies and gentlemen? Y equals what?
mx plus b.
Okay, y equals mx plus b. Well, check it out. I've got my m right there. I've got an x right here. I've got a y right there. I'm just going to plug all that stuff into this equation. Y equals mx plus b. What's 14.6 times 1? 37 equals 14.6 plus b. All I need to do to figure out what b is take 37 minus 14.6. 37 minus 14.6. That equals 22.4. So b is 22.4. All right. Get that out of the way. Okay, now that I've got all that, I've got enough to write the equation. Y equals mx plus d. Take this over just a little bit further. It's a little bit large, so shrink it down, get it out of the way. All right, what I have here in green now, this is my equation. It's the magic equation that's going to make a prediction. Okay? Now, how do we use this equation? They want us to predict what sales are going to be in September. All right? September, is that the 1st, 2nd, 3rd, 4th, 5th? Which month is that? 9th month. So, I'm going to use a 9 for X. I'm going to put a 9 in there for X. All right. So, Y equals 14.6 times 9 plus 22.4. That's the equation I need to work out now. No, it's just the right amount, you'll see. 14.6 times 9 plus 22.4. I've got 153.8. Now, what does that mean? That's our prediction. Take a look at the trend line here. Our prediction was 153.8. If I go over here to September to 153.8, which would be right about here, Is that on the line?
Yeah. Yeah.
Yep, the line would go right through that, wouldn't it? Okay? So all this work to get this one answer right here. All right? Now, a couple other pieces of caution, words of caution on this. If you use a different set of points than you, your equation's going to be different. If your equations are different, your final answer's different. Does that mean it's wrong? Not necessarily, because if your final answer falls somewhere within this area of this line, you're going to be just fine. Okay? Because if I had used, instead of using those data points, if I had used something else, like that data point right there, I would have gotten an entirely different equation, and my answer would have been down here somewhere. Okay? See what I'm saying here now? So the only way that you know if you've done the math correctly is if your final answer falls somewhere within your line. All right? Okay, that's all I've got for today. Let me get this right there and do this.